All right, let's look at some triple bonds. Rather than starting with our notes for the triple bond, I want to show you this is a continuation from that oxygen that we saw in the last example. I want to show you the triple bond and how it's formed. So remember I mentioned triple bond, it has one sigma bond because that's always the first bond that's formed. Then we'll have one pi bond forming the double and a second pi bond to form the triple bond, or the 3 bonds. So a triple bond is going to be made of 1 sigma and 2 pi bonds. So up here we have nitrogen. These are all the p orbitals. So we have px, py, and pz. The first bond that's formed is our sigma bond. That's the head-to-head overlap, and that overlap occurs in between the 2 nitrogen atoms. The first pi bond is an overlap from our pz orbitals. So we have the overlap above and below. That formed the second bond, or the double bond. Nitrogen does have a triple bond, so what's going to happen is we're going to overlap the other p orbitals. Okay, so now we have electron density coming out at us and going away from us. So let's also look at this example using our carbon molecule. So looking at triple bonds, we want to kind of do our promotion or promoting from our carbons. This is acetylene. We have carbon, triple bond, carbon, and then our hydrogens on either side. So again, we start with our electron configuration of carbon. We have 2 electrons in the S and 2 in the P. We're going to promote one of our electrons to our P, just like we did before. All right, we're promoting. So we have 2S, 2P. Oops. Now we hybridize. Remember, we only hybridize what we need. So here we have 1 area of electrons, 2 area of electrons. So we only need 2 orbitals. So we're going to take our 2s and 1 of the 2 p's. So we're going to end up with, we had 2 atomic orbitals. We're going to end up with 2 hybridized orbitals, and they're going to be of the sp hybridization. Then we have remaining, this will be the py and the pz. Remember, we have 2 carbons like this. And then we have our hydrogen. Each hydrogen has 1 electron in the 1s. So 1 hydrogen is going to overlap with 1 of the sp hybrid orbitals. Then the other hybrid orbital on 1 carbon is going to overlap with the other hybrid orbital of the other carbon. Remember, that will be our first bond formed. That's the sigma bond. So the overlaps that we're talking about of the sigma bond, that first overlap that occurs with our hybrid orbitals, we have the hydrogen to carbon bond. So this is a sigma bond. Same thing over here, sigma bond. Then the other hybrid orbital of each carbon is what's overlapping to form the sigma bond there. Then in these two pictures, we have the second bond and the third bond occurring. So this is the overlap of our py and our pz orbitals. So we have overlap above and below. Then we have our py orbitals overlapping. And this is coming out at us and going away from us. And so I kind of crudely did that as dashes, and then kind of a more solid line around there, right? These are coming out and away from us. Another way to look at it is looking at this view, kind of looking down our molecule. We have the sigma bond in between, and then the pi bond above and below. Remember, it's the side-to-side overlap, so we get two different locations of where those electrons are, but that's one bond. Okay, so we have above and below, and then coming out at us and going away. So these bonds here, this is pi bond number 1 and pi bond number 2. So in a triple bond, we have 1 sigma bond and 2 pi bonds. Definitely worth knowing there. For our double bonds, so going back a page, what color should I use? I stay black. 1 sigma bond and 1 pi bond. So that's in a double bond. We have 1 sigma and 1 pi. In the triple bond, we have 1 sigma and 2 pi's for the 3 bonds. Next video, we'll look at some examples of what is our hybridization, correlate that to our overall shape of our molecule, and what types of orbitals really are doing the overlapping.